Now, once we know how to deal with momentum, once we know how to calculate it, mass times velocity, once we know its unit, kilogram meters per second, and we're probably happy with using it to describe safety situations, we then get to the most difficult situations. Here, it's really important to know two things about momentum. Number one, momentum has direction. Now, you've probably noticed that I've been talking very carefully about velocity. Momentum is mass times velocity, not mass times speed. Speed just tells me how fast something's going. Velocity tells me what direction. And the fact that I'm using velocity here tells me that momentum also has direction. So if I tell you that a car travelling has 3,000 kilogram meters per second of momentum, you should ask me, well, in which direction? Is it travelling forwards? Is it travelling north? Is it travelling up? Which would be very unusual. So momentum needs to have a direction. Now, at GCSE, this is quite straightforward because we will just talk about having positive momentum and negative momentum. So if you move forwards, you might decide to call that positive momentum, and then if you move backwards, you would have negative momentum. It doesn't really matter which way is plus and which way is minus as long as you're consistent. The second thing about momentum is that unless there's an outside force, so if you've got a closed system, two objects that only interact with each other, so for example, if I run into another person, we run together, now assuming that the only forces are me hitting him and him hitting me, then momentum is conserved. And what does conserved mean? Well, it means that the amount of momentum stays the same. If you like, you can write an equation that says momentum before equals momentum after. And this gives you the ability to start working with collisions. So let's imagine for a moment I'm a snooker player. Here's the white, and I've decided that I'm going to take on this red over here. Now at the start, I can work out the starting momenta. How do I do that? Well, I know the mass of this ball. I know what the mass of this ball is, and I know how fast it's going. I'm sure an exam would give you that question. I might know the mass of this ball, and I know that it's got zero velocity, which means it's got no momentum. So in this situation, these two balls have a certain amount of momentum between them. As it happens, the white ball's got all of it. Now let's imagine that I play a stun shot, and so my white ball stays still, and my red ball flies off, hopefully into the pocket. Now my red ball has gained some velocity. It's got the same mass, but now it's got a velocity in this direction. The white ball, however, now has a velocity of 0. So you can see this velocity must be the same as that because momentum has to stay the same. The amount of momentum these two balls have together is exactly the same as the momentum they have afterwards. Momentum is conserved. So you can do the calculation and work out exactly the speed that this ball is moving at. Slightly more complicated example. Let's imagine that a car is driving along and it's got a mass, it's got a speed in this direction, and it plows into the back of a lorry which is stationary. Afterwards, the car actually gets stuck to the back of the lorry, it manages to get wedged underneath, and so you end up with one object with a really big mass. There's a mess of mashed up car under there somewhere, and they're moving off together. So they've got a velocity together. No momentum. Some momentum, exactly the same amount of momentum must be there at the end. So the momentum from this car is now shared between the car and the van. Even more complicated. Let's imagine for a moment that I have a gun. This gun has a certain amount of mass and a velocity of 0 because I'm holding it perfectly still like a good marksman, and then I fire the gun. Now when I fire the gun, a bullet comes out. And this bullet flies off in this direction. It's got a very small mass, but it's got a really big velocity. The gun over here, it has a mass, which is slightly less than it was because it's lost a bullet, but it must also have a velocity because this has no momentum. So there can be no momentum here overall. Because the bullet's got some positive momentum, the gun must gain some negative momentum and it will move backwards. That's why guns recoil.